What is machine learning? Machine learning is a method of data analysis that automates analytical model building. It is a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. Machine learning is the science of getting computers to act without being explicitly programmed. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning. Supervised learning is the process of training a model on a labeled dataset, where the correct output is already provided. The model learns to predict the output for new inputs based on the patterns it discovers in the training data. For example, a supervised learning algorithm for email filtering may be trained on a dataset of 100,000 labeled emails, where the labels indicate whether a given email is spam or not. After training, the algorithm can predict whether new incoming emails are spam or not. Unsupervised learning. Unsupervised learning is the process of training a model on an unlabeled dataset, where the correct output is not provided. The model must discover the patterns in the data on its own. For example, an unsupervised learning algorithm for market segmentation may be trained on a dataset of customer data, with no labels indicating which customers belong to which segment. After training, the algorithm can group similar customers together. Reinforcement learning. Reinforcement learning is the process of training a model to make decisions in an environment where the model receives rewards or penalties for its actions. The model learns to select actions that maximize the expected reward over time. For example, a reinforcement learning algorithm for playing chess may be trained by playing against itself millions of times. After training, the algorithm can play chess at a superhuman level. Machine learning algorithms are categorized into two main categories: parametric and non-parametric models. Parametric models. These models are defined by a fixed number of parameters and make assumptions about the functional form of the relationship between inputs and outputs. Examples of parametric models include linear regression and logistic regression. Non-parametric models. These models do not make assumptions about the functional form of the relationship between inputs and outputs. Examples of non-parametric models include decision trees and random forests. Machine learning models are trained using different techniques such as gradient descent, stochastic gradient descent, and conjugate gradient. Gradient descent. Gradient descent is an optimization algorithm used to minimize a cost function. It works by iteratively moving in the direction of the negative gradient of the cost function with respect to the model parameters. Stochastic gradient descent. Stochastic gradient descent is a variant of gradient descent that updates the model parameters after each training example, rather than after each epoch. This makes the algorithm faster, but also less stable. Conjugate gradient. Conjugate gradient is an optimization algorithm used to minimize a cost function. It works by iteratively moving in the direction of the negative gradient of the cost function with respect to the model parameters. There are several challenges in machine learning, including overfitting, underfitting, and the bias variance trade-off. Overfitting. Overfitting occurs when a model is too complex and fits the noise in the training data. This causes the model to perform well on the training data but poorly on new, unseen data. Underfitting. Underfitting occurs when a model is too simple and is unable to capture the underlying patterns in the data. This causes the model to perform poorly on both the training and the new data. Bias variance trade-off. The bias variance trade-off is the trade-off between a model's ability to fit